Netflix, 700 million subscribers, 190 countries, at peak hours, over 1 million concurrent streams. 700 million people, every one of them expects instant, uninterrupted video. At peak, over 1 million streams every single second. Netflix alone accounts for 15% of all global internet traffic, more than YouTube, Facebook, and Amazon Prime combined at peak. Yet, when you press play, your video starts in under 200 milliseconds, almost anywhere on Earth. How? So, today we go deep into the system design that makes this possible. Stay tuned. Before we talk about Netflix solution, let's understand the problem they had to solve. Imagine all 700 million users hitting a single server. Obviously impossible. It would collapse under the weight of just a few thousand requests. So you add more servers, but now which server handles which user? How do you route 1 million concurrent streams without a single point of failure? And video is different from text. One HD stream is 3 to 5 gigabytes per hour. Serving video at Netflix scale means moving petabytes of data every single day. You need a completely different architecture. Netflix solution splits the system into three completely separate tiers, each optimized for a different job. Tier 1, the client. Every device runs a Netflix application, smart TVs, phones, browsers, game, consoles. The app handles playbook, buffering, and adaptive bitrate. Tier 2, the backend. Running entirely on AWS, this handles everything except video, login, search, recommendations, billing, user profiles, and the content catalog. Tier 3, Open Connect. Netflix on private CDN with over 1,000 server locations embedded inside internet service providers worldwide. This serves all video. The critical insight, video never touches the AWS backend. It flows directly from Open Connect to your device. That separation is what makes this system scale. Open Connect is Netflix's secret weapon. It's a private CDN content delivery network that Netflix built themselves rather than paying a third party. Open Connect appliances are physical servers that Netflix installs directly inside internet service providers and internet exchange points around the world. There are over 1,000 OCA locations across 6 continents. When you stream in Mumbai, the video comes from a server in Mumbai. In Chennai, it's from Chennai. So this eliminates the longest and most expensive part of video delivery, the long haul network journey across continents. Netflix fills these servers with popular content every night during off-peak hours, pushing the content closer to viewers before they even request it. Let's go deeper into how an individual Open Connect appliance works. Each OCA is a purpose-built server, high RAM, fast SSD storage, and a very fat network pipe directly into ISP's backbone. Every night between 1 a.m. and 6 a.m. local time, the filling process runs. Netflix backend analyzes what content is trending in that region and pushes it to the local OCA. Content is stored in multiple formats and bitrates, from 240p for slower connections all the way to 4K HDR at 15 megabits per second. When you press play, the Netflix app negotiates with the nearest OCA, checking which bitrates are available and what are your connection speed supports. This is called adaptive bitrate streaming. Every known video action, login, browse, search, press play, goes through the API gateway. Let's trace exactly what happens. Your device sends a request over HTTPS. The first stop is a load balancer. It distributes incoming traffic across multiple gateway instances to prevent any single point of failure. The API gateway receives the request and immediately does three things in parallel: rate limiting, authentication, and routing. Rate limiting checks if you are sending too many requests. Authentication validates your session token against the user service. Routing determines which downstream service should handle this request. So only after all three pass does the request flow to the appropriate microservice. The total overhead added by the gateway is under 10 milliseconds. Netflix runs hundreds of microservices. Each one owns a single responsibility and can be deployed, scaled, and failed independently of each other. When you press play on a title, at least 8 services respond before your video starts. The streaming service is the critical one. It resolves which video file to serve, in which format, and which Open Connect appliance is closest to you. The recommendation service runs a machine learning model trained on your entire watch history to decide what appears on your home screen. All these service calls runs in parallel using a reactive programming model. The response is assembled only when all required services have replied. Netflix doesn't use a single database. Different data has very different requirements, so they use different storage systems optimized for each use case. User profiles, watch history, and preferences go into a distributed wide column database optimized for massive scale reads and writes with no single point of failure. The content catalog, titles, metadata, episode detail lives in a relational database. This data changes infrequently and needs strong consistency. Viewing activity events, every play, pause, and seek stream into a time series store optimized for high volume sequential writes. Caches sits in front of every database, reducing load and bringing response times down from milliseconds to microseconds. Databases are fast, but at Netflix scale, even a fast database becomes a bottleneck when you have hundreds of millions of users hitting it simultaneously. Netflix uses a distributed in memory cache deployed across multiple regions. The cache sits in front of almost every database in the system. For user data, profile, preferences, watch history, the cache hit rate is over 99%. That means only 1 in 100 requests actually reaches the database. For the content catalog, caching is even more aggressive. A title's metadata almost never changes, so it can be cached for hours or even days. This is what allows Netflix backend to serve millions of requests per second without the database failing over. With hundreds of services and thousands of servers, failures are not a question of if, they are a question of when. Netflix philosophy: stop trying to prevent failures, instead, assume failure happens constantly and design your system to survive. They built a tool called Chaos Monkey that runs in production and randomly terminates service instances every single day. The logic is pretty simple. If your services can't survive Chaos Monkey in normal operation, it will definitely fail when there is a real incident at 2 a.m. When a service fails, circuit breaker opens automatically, isolating the failure and preventing it from cascading. Fallback responses serve degraded but working results. Every interaction you have with Netflix generates an event: play, pause, rewind, search, hover, abandon, all of it. These events flow in real time into a distributed message queue. Netflix processes over 700 billion events per day through this pipeline. From this queue, two separate pipelines consume the events for different purposes. The real-time stream processor consumes events within seconds. It updates your continue watching list, adjusts what's trending, and detects quality issues in active streams. The batch processor runs every few hours. It feeds a much larger dataset into the machine learning training pipeline, retraining recommendation models with fresh data from millions of viewers. Let's bring the whole system together and trace one complete request from pressing play to the first frame appearing. Your device sends a play request over HTTPS. The load balancer distributes it to a API gateway instance. The gateway, it runs auth, checks your subscription, and fans out to the streaming service. The streaming service queries the content catalog, which file to serve, in which format, at what bitrate. It also queries the OCA selector, which of the 1,000 Open Connect servers is closest to you right now. The response comes back to your device with a URL pointing directly to an OCA. Your device connects to the OCA and video starts flowing, bypassing AWS entirely. Total time from press play to first frame is under 200 milliseconds. 5 things to take away from Netflix system design. 1. Separate your concerns. Video delivery and API traffic are completely different problems. Solve them with different systems. 2. Get close to your users. Netflix built a private CDN specifically to eliminate the distance between video and viewers. 3. Design for failure. Chaos engineering, circuit breakers, and fallbacks mean a single service failure never becomes a user visible outage. 4. Cache aggressively. A 99% cache hit rate means your database only handle 1% of the actual load. 5. Let data drive decisions. Every interaction feeds a pipeline that improves recommendation, quality detection, and the product itself.